Any other question?
No, we can start, sir. No problem.
All right. So any idea about the QoS? What is QoS basically and why we need it?
Uh, it is used to prioritize the traffic.
Yeah, that's right. Okay. So basically, when network was developing, along with we we were facing lots of issue. When let's see if we talk about the PSTN. So it's a kind of a voice network which is carrying the data. Okay. So if you cannot carry the both the thing at the same time, right? So it took a long time to create a separate data network like Ethernet, or ATM, or your Fremle kind of, or X.25. So when network got evolved, along with we were facing the resources limitation, right? So QoS is a term by which we can. So QoS is just a term, but it has many technology in it. Okay, so by QoS you can organize your traffic in the network. Okay, why we need the QoS basically? So let's talk about it. So basically, so QoS. Okay, so basically, what are the things we'll get in our network? Okay, so QoS refers to the ability of network to provide improved service to selected network traffic over various technologies. Uh, it doesn't matter like you are using a lease line or anything. It is always recommended to enhance your resources, but it is not always feasible to add new circuit in your network or to add new device in your network. So sometime if it is not possible, then we can move to the QoS feature. Okay, what QoS can provide us? So QoS can provide me a dedicated bandwidth, improved loss characteristics, congestion management and avoidance, traffic shaping, and prioritize of the traffic. Okay, so these are the segment of the network we can improve by the QoS. First, dedicated bandwidth. We can allocate a dedicated bandwidth to the sensitive traffic. So we have a category of traffic now. It's not like simple data traffic we are carrying over the network. So we are carrying the voice traffic. We are carrying video conferencing, live streaming kind of thing. So uh, nowadays we have various application, various network, various different types of network traffic. So in that point, some are the sensitive traffic, some are not sensitive for the delay or loss. Like voice, it's very sensitive traffic. If we lost any traffic or any or few packet, will not be understand what is the meaning of the sentence and whatever, right? So in that case we need these to be dedicated. So generally for voice, if it is more than 150 millisecond delay, then your voice will not be clear. So it has to be less than 150, and it's not like 1.2 next point, it's end to end. So end to end you should have that kind of quality over your network. So you can increase, it's not like increasing your bandwidth, it's organizing your available resources basically. Okay, so if you have 10 MB data, then we can organize that, or we can divide that 10 MB in a prioritized manner. Okay, so dedicated bandwidth improve the loss characteristics, congestion management, and avoidance basically, traffic shaping, which generally your service provider will do. Okay, and what are the goal we are looking at? Basically, what are the enemies of your network? Okay, first, delay. Okay, delay, jitter, and all will cause a loss. So loss can be result by the other way, uh, any physical error in your network, or your corrupted frame, congested network, all, or delay and jitter can also cause a loss else also, or some of the application which does transmission or retransmission basically. So there we can say that this is a kind of loss we have. Okay, so what is delay basically? So delay or latency, it's the same term. So delay refers to the time it is taken for a packet to travel from a source to the destination, right? There are again various type of delay, so we'll talk it about later. Okay, so how QoS has evolved. When we were facing this kind of issue in the network, we were not having any mechanism to uh, organize the data. So in 1994 we got the first QoS mechanism, or it's not the kind of mechanism, it's a first in first out we say, and in general term it's best effort. We can say type of QoS. Today we'll talk about only the terminology. So from tomorrow we'll start the lab practice on this. So best effort, also in Cisco we can say it's FIFO now, FIFO. In Okay, so later on we got another QoS model, that is your integrated services. This name came from the ISDN basically, integrated services digital network. So integrated services are in short INTSERV. Then differentiated services, services, and later on some advanced QoS like MPLS traffic engineering, QoS intelligence or auto QoS, automation, and QoS as security tool. So we can use QoS in any these kind of, so any types of QoS. Okay, so let's say, so basically nowadays it's we used to do your QoS by differentiated services These are optional if you want. If nothing is using, then this one will be the best one. Okay, so by default it's a best effort. Okay, so let's say if I'm having an interface, exit interface. Okay, it's a exit interface and I'm having different types of packet. Let's So every physical interface will have its own buffer size. Okay, as soon as for what is first effort uh, QoS? So first effort means as soon as you will hit a packet, it will send it out. It's as simple as we can see, and this is the what we say. It doesn't have any intelligence. Okay, it will not have any priority over the sensitive traffic or anything. So it's a simple method. As soon as your interface will hit the traffic, it will pass that on. Okay, so it is basically the first one is not recommended for any sensitive traffic like voice traffic. So it's a normal behavior in our network. Okay. Okay. All right. So next one is your integrator services, introduced around 1993 and 94. It has the RFC also, so it runs your on top of your signaling protocol that is called RSVP. Let's remove it. Insert. Okay, so in serve, I would say even in CCIE it is not covered too much, only 2 or 3% of the QoS part. So 98-95% you will get the differentiated services. Okay, because it's not too that much scalable as in compared to your uh, differentiated services. Okay, so in serve it works per flow. We can say working design, so it works as per flow. uh, it it uses a signaling protocol, and that is your RSVP. It's I think RFC number should be 1633, but we can double check it on website. Okay, so resources reservation protocol. We have some use of this protocol in MPLS traffic engineering. It is used to distribute your label, but in real time scenario, if we are using it for the QoS and to reserve your resources, this is bit it's basically not scalable. What it does basically, let's say I have an end-to-end service. It sends a signal. So this is my circuit. Okay, so if I say let's reserve 36 Mbps for voice, so it will send a signal. Each hope should agree on this and then it will complete that reservation. Okay, if anyone disagrees on that, then it will not reserve that bandwidth for the voice. So it's a kind of mm, and moreover, if you are not using that bandwidth, so no one else will be using that bandwidth. So it's kind of dedicated. You have assigned the 36 Mbps speed to your voice traffic. Similarly, so you can have another. So it's not possible to create the reservation for each protocol, and it's not feasible as well. Okay, because every if my in between any router is not supported RSVP, that might block your all the plan and other things. Okay, so integrated services, the application requests a specific kind of service from the network before it sends the data. Okay, uh, it's not uh, required the continuous signaling of network devices in this. So if there are some benefit of RSVP as well, we can recommend it for the voice, but again we have to use it as end to end. Okay, so basically in a router in a conjunction with the RSVP are able to use intelligent queuing mechanism to provide two types of services. One is guaranteed rate services, which will allow you to provide the fixed transmission rate kind of voice or video you can give, or controlled load service, which allows application to have low delay and high throughput even during the time of congestion. So these two kind of but we'll not talk about too much. I will not talk too much about it. So let's say differentiated services. DHCP, differentiated services code point, or Diffserv model. Okay, so Diffserv model is was developed by the IETF. In this, it we generally call it per hop behavior (PHB). So each hop can act or behave according to its configuration. Okay, it's not flow based now. So each hop can take decision how to forward or prioritize the data in per hop behavior. What is the beauty of this QoS mechanism is it will integrated your marking inside your IP packet, or if it is your layer 2, then it will have cost value. Okay, so basically each packet will have the classification upon the entry of your in the network. So as soon as your packet will enter in your network, it will have a classification, and according to that classification, whatever we called it, we'll talk about it, TOS or COS, or your your D bit, or that will decide how to forward that traffic. Okay, we can do that classification on access layer switches, your router. So we are flexible over there, so each device can take its own decision. Okay, but the only pain is you need to configure it on each devices. So but again, if you have enough resources, so you don't need to do any marking, or so by default it will go. If there is no marking, it will match to the again default behavior, which is your best effort or first in first out, FIFO. Okay, so unlike int-serv model, Diffserv doesn't require network application to be aware about the QoS like we have this one. Okay, okay, all right. So let's talk about the Diffserv now. Mm, we have different types of 1 second. As per the layer architecture, okay, we have different QoS mechanism, or Diffserv method. Okay, all right. So so okay, so for IPv4 and IPv6, we can say it's a type of marking, how we can mark a packet. Types of, okay, so for IPv4 and IPv6, we call it TOS, byte. Okay, and for for layer 2, so this is for layer 3. 2, it's frame relay. So let's say if I'm using frame relay, it's frame relay DE bit. It's only 1 bit, so either your value will be 0 or 1. Okay, so if you are receiving two frame at the same time, and one is having with 0 value and one will be, another is having 1, and in time of congestion one will be dropped first, then 0. So this is how a framelet DE bit will work. Okay, in MPLS, this is called experimental bit, EXP bit. The size of this is 3 bit. Okay, so you can get the 8 different classes with these 3 bit and different priorities. In 802.1q, or just say .1q, 1q or ISL, it's called COS bit. It's again 3 bit value. So with 3 bit you will be getting 8 different classes, 0 to 7. Okay, in DHCP and sorry, your TOS byte, we can categorize it in two different category. One is DHCP, and another one is your IP precedency. IP precedency. So DHCP is 6-bit value. Total you will get 64 classes. So we have more flexibility here to define your type of traffic. It's again 3-bit IP precedency. It's a legacy. It is backward compatibility with your CoS. You can say again it will create a 8 classes. So how it works basically, so let's say if I'm receiving a traffic, let's say this is my router going to internet. Okay, so let's say I have different devices, I need to treat it differently. So let's say this is video conferencing I'm using. So by default, if I'm using video conferencing and it's using email, so what will happen? By default, it will be a FIFO, a first in first out, or your uh, best effort. So there is no difference on this. Okay, so means as soon as if my voice is video is coming, then it will treat the same. If it is email, or email will not disturb you too much. Maybe it's let's say FTP. So FTP is greedy traffic. Okay, so it's if you're using FTP and video conferencing at the same time, so there will be a chance where FTP will take the all the bandwidth of your interfaces and your video will drop the quality, or maybe there will be a difference. Okay, but same time, so let's say I have categorized the traffic now and we have set a marking here. Okay, we can set we have to set it on the interface basis. So let's say I have marked it as a high priority, let's say 40. This is just an example. So what will happen, as soon as the traffic of voice will come, there will be a 8-bit field in your IP header which will be marked as a 40. So by default that will be 000. Okay, but if it is marked as a 40 and I'm prioritizing that data in egress, so what I have applied here, a policy which is saying that if it is receiving a traffic of QoS 40 or DHCP value 40, that should get prioritized instead of other traffic like FTP and other. Okay, so this interface will process the traffic even though it is coming after your FTP. So it will prioritize the data and forward it to next. Same thing you can do here. So the marking will be done only one time, so it will be there at until it reaches to the destination, until unless you don't have any mm, devices which is not supporting this. So there are some devices like multi-layer switches which will raise the all the existing marking, so we can enable the trust over there, but default feature is they will treat every traffic as a default traffic, or yeah, we can say it's without any priority. So that in that case we need to make it as a trust interface, or else your marking will be all the way to destination, it will be there. Okay, so let's say it reaches to here and in egress queue. So the queue will be in both sides, egress and egress also. So as soon as it has the higher priority value, it will process the traffic in compared to your other traffic. So this is how it works basically. It's a simple process. Any doubts so far?
Sir, one doubt.
Yeah.
So in normal case,
Mm-hmm.
so we have many router, many home.
Uh-huh.
So in that case, so let's say I have five router. My source is located uh, in India, and my destination is in US,
Uh-huh.
and I need to cross five hops to reach the destination.
Okay.
Okay,
Mm-hmm.
so what is the logic? So where we can apply the QoS? Can we set a QoS for the forward traffic or the return traffic?
Yeah. So QoS should be the nearest over the nearest host. Okay. So from the beginning, it will be getting marking and prioritized. Okay. But if you don't have it at the nearest host, then over that hope, which is having the lack of resources, right? So that there we can use it. But this is always recommended to use the QoS at the nearest host, because as soon as you will prioritize the data, or you will mark the data, and even though a next router doesn't require it has the enough resource. Let's say I'm having only, because each router will have the different capabilities, right? So let's say this link is only 2 Mbps, 2 point something. Let's say it's E1, 2 Mbps, and this router is connected with the 100 Mbps with the different resources, let's say. So in compared to this link, we don't need any QoS over this one, right? So it's up to your requirement. So if this link needs to process your video or voice traffic quickly, we can prioritize that traffic over this interface. But as soon as it will reach over this router, we don't need that to be prioritized here, because it already has the enough resources. Okay, so two options I can suggest to you. One, the router which is having less resources, and if you are using the same resources, so all the way to from beginning to end, so it is always recommended to use it on the first hop, or nearest to the your source, right?
One more out.
Yeah.
So as per the scenario which we are talking about,
Hmm.
so first the traffic will be prioritized, right? That should happen,
Yeah, in ingress
and
it will be
that should be
prioritized.
okay. That means in the router.
Yeah,
So
as I
what
said,
we will do in the egress,
in egress, yeah.
egress we will already manage.
Yeah, so in egress we can allocate the bandwidth for the prioritized data. It's not like I have prioritized the data and interface will take intelligent decision to forward the traffic, right? It's not like that. Until unless you don't have any priority system and you have not assigned any dedicated bandwidth to that prioritized data. So let me clarify it. So it has two steps. Okay, first marking, and second policy. Okay, so you can mark your traffic while ingress traffic. Okay, and while sending it out, you can provide the you can apply the policy basically to say, if I'm receiving voice traffic, give it to, or it's not like voice traffic I'm recognizing the marking value. If I'm receiving receiving marking value of DHCP 46. This is the uh, marking we use for the your this one voice. So what we'll say in policy, if I'm receiving a traffic with DHCP 46 value, give the dedicated bandwidth of 40 MB or something, whatever you want. Okay, so that will be defined on the in egress port. So two step in ingress port, we'll say if it is receiving traffic with this subnet or this protocol, mark that value as 46. If I'm receiving FTP, mark that value as 20. Right? So this is marking in basis of your protocol, in basis of your subnet or any IP address. You can do with the any uh, uh, what we say classification. So we are categorizing the traffic. It's in the behalf of your IP or your protocol, and then we are marking that this is the value of DHCP. So once your DHCP value will be integrated inside of your IP header, then in egress we can decide what to do with that, and we can combine the both thing. Okay, so we can do like marking and polishing at the same time in egress port. So both the options are there. Okay.
Yeah, go ahead. I hope when we start doing lab, I will get more ideas.
Yeah. Okay. Yeah. So these are the just bit assignment. How many bit it has and how many different class it will create. So let's see next. Okay. Okay. So in as I said, it's a 6-bit value. Before that, I can explain this one also. Okay. What was that? And this. Okay. So I was explaining like every traffic is different in network now. So if you compare the data, voice, and video, uh, voice is smooth, drop sensitive, delay sensitive, and it's based on the UDP. Video has the same, but it instead of your smooth, it's a bursty traffic. But if you are using as a video conferencing, so that became again sensitive. So it should be the uh, it should be having the higher priority than other data. Again, if you are using a data like email or any other that has, so those will be the TCP based. So even you lost that, it can use retransmission. So it's not delay or your drop sensitive. You can still get your data. So according to that we can prioritize the data. Okay, so I was talking about the delay. So packet loss, it is always countable. Everyone needs their data as 100%, especially in voice. So if you are losing your voice traffic, then it might be a big issue. Okay, so as I said, packet loss can be because of anything. In delay or latency, so I was talking about delay. There are in a network there are subcategory of delay. How in which area we can get the delay? There will be a fixed amount of delay, and some mechanism are which some mechanism are there which we can control. Okay, so this is a finite amount of time that it takes a packet to reach or reach the receiving endpoint after being transmitted. So this is the general theory about the data. In data network, carrying voice and fixed network delay, we can say it has three types of delay. It's packetization delay, serialization delay, and since voice is UDP based, we don't have any way to recover it or get the retransmission. Okay, even we get the retransmission, that will not be in a sequence and will not be able to understand that one. Because and propagation delay. All right, so packetization delay, the time requires to sample and encode voice or video signal into packet. So basically when we talk over the phone and on any IP phone, it will be in uh, what we call that. Okay, so to convert that voice in digital, that will be your packetization delay. Okay, serialization delay, so basically the time which it takes to convert your analog signal to digital, that is your packetization delay. Okay, serialization delay, the time requires to transmit the packet bit into the physical media based on the clocking rate of the interface. There we generally set the clocking rate in the serial also, but there will be a default clocking rate on the other media as well, like your Ethernet and other. And propagation delay, the time requires for the electrical or optical pulses to travel the media all the way to your destination. That is your propagation delay. Okay, so three types of delay you can face. There will be a field again that is called jitter. It's not differ than your delay. It's a part of delay, but it's a little bit difference between your delay and jitter. So let's say I'm having one phone over here, another phone here. This is my network connected. Okay. So let's say my one packet has taken amount of traffic time to reach the destination. So let's say it's a 10 second. Okay, second packet which I have sent has taken a bit more time to reach out the destination. Let's say it's 18. So what is the jitter value now? So what is jitter? Basically the delay delay between two different, sorry, difference between two delay packet will be called jitter. So here 18 minus 10 means your jitter value will be 8. Similarly, if it is increased, so let's say third packet is taking 25. If sometime it goes more than 30 millisecond, okay, the variation between two delay will be your jitter. Okay, so if your variation goes more than 30, that will cause a drop in voice. So it should not cross your 30 millisecond. Okay, so this is the one which I was thinking to explain. All right, so we'll talk about the how DHCP and your marking will work and what are the classes we have basically. Okay, so let's talk about that. Okay, so default it's best effort. In Cisco we can say FIFO. DHCP value for that one is 0. In binary you can mention it 0000000. Okay, and the opposite of your default can be EF bit. I always forgot this name. It's expedite forwarding. Yeah, expedite, or we can say expedite forwarding. So it is used for the priority traffic for voice. If we say okay, DHCP value will be 46. In decimal, sorry, your binary, it will be 0 1 1 1 1 0. Yeah, 2 4 6 8 12 or 14. Okay, yeah, 46. Hmm. Then so these are the two value which we can see. Let's say about the other DHCP value. So we have default EF. Let's talk about another one, AF. This is called assured forwarding. Okay, it gives you bandwidth guarantee. It has four classes basically, AF 1 to 4, 1 to 4, and 3 drop precedency. Okay, higher will be most preferable. So 1 is the least preferable and 4 is the highest preferable, and 3 drop precedency. Okay, so it has the value of 1 to 3. Higher means more drop sensitive. So we generally write it like AF, sorry, AF X and Y, where X is your assured forwarding value, or your these classes, and your Y represent the drop precedency. So which class it will be and which drop precedency it will be. So let's say if I'm talking about AF11, AF12, AF13. So class is 1, but it has three different drop precedency. So if I say this is my mail, this is my ICMP, and this is my, let's say, FTP. Okay, so if I'm receiving all the three kind of traffic at the same time, what will happen in congestion? Your FTP traffic will be dropped first, then ICMP, and then in last your mail. So the higher the number you can see in Y value, that will have high drop precedency. Okay, let's compare. So this is just one class example. So let's say if I'm comparing it with AF112, AF23. So this is different class now, AF2. So means if you compare, if you are receiving traffic which is marking with AF11 in compared to 23, that will drop first. So which this will be drop first. So in this category, assured forwarding, your AF41 will has the highest priority, right? In place. So higher the value in class, that will have higher uh, preference, and if you are having higher number in Y value, then it will have higher drop precedency. Okay, give me 1 second. And you can calculate the decimal value of this one also. There is one formula. Okay, so AF11 BRB. Okay, okay, so formula is I think 2 into 1. Okay, it's 8 x into, that's x into 8 plus y into 2. So you will get the decimal value. This is the formula to calculate. So let's if I'm saying about the DHCP AF11, AF11, the decimal value will be, so this is my x, this is my y value, So what will be 8 into 1 plus 2 into 1 is equal to 10. If I'm talking about AF12, it's not necessary to remember all these things, but just to get the better understanding. So 8 into 1 plus 2 into 2. So it means 8 plus 4, 12. So similarly, you can get the value of AF41. So 4 into 8 is equal to what? 32 plus 2, 34. Yeah. So like this. Okay. Any doubts so far?
Didn't know.
No? Good. Okay. So this is the TOS byte we say. Now we'll talk about the class selector, which is your integrated services. Okay. So these bit whatever I was talking about, that is DHCP. Okay, how to do it. So as I told you, uh, class selector has the backward compatibility with the IP precedency in DHCP bit, so you can use it from straight away 1 to 7 CSX we say. Okay, the higher value will be most preferable. I have one slide which you can use for your reference. TCP IP. Okay, where it was, should be here, data. Okay, so this is the according to RFC DHCP value. You can see it's a routine traffic in IP precedency 00. It's a routine. Okay, and it's 0 to 7. You can see priority traffic 1. It's 8 to 15. So we can categorize our email and all things. This is immediate, uh, 16 to 23 in DHCP. Flash, so basically it is used for the signaling, uh, like you are sending the ringing, means your uh, phone ring and all those things, that is called as flash. And it has the range of you can classify that traffic and DHCP value 24 to 31, and in binary you can say like 001 and 00. Flash overwrite, number 4. This is usually used for the video 32 39. Then critical, which is your voice 40 to 47, and then your inter-network control, that is similarly 48 to 55, and then network control, that is control plane traffic 56 to 63. So we cannot assign any these two to any protocol. So 5 is the maximum, or 46 or 47 is the maximum value which we can assign to a data traffic. By default, other will be reserved for control plane traffic. It has the um, by default integrated marking. We can still assign it, but again, if it is a control plane, that means it will take care all the resources. So it's high priority, like your OSPF, your IGMP, your CDP, any protocol which needs to be processed by the CPU, that will be treated as a high priority. Okay, or your network control or inter-network control. I hope this will give you some idea what we are talking about, right? So if we talk about, so these 3-bit, last 3-bit, you can say it's assured forwarding, sorry, your drop precedency. Hello? Okay. Yeah, Arun, can you see my screen? Arun?
Yeah, yes, sir. Go ahead.
Yeah, so you understand this slide,
Hello.
or yeah? Hello.
Yeah, no problem. Carry on.
So you understand
Hello.
this slide?
Yes, yes.
Okay. Okay. All right. Mm, so it has the same information. So you can see here, low drop precedency 1 1. Then so these are the classes: class 1, class 2, class 3, class 4, which I was explaining. Okay. So in drop precedency, you can say in class 1, 1 1 has the lower drop precedency in place instead of here 1 2 and 1 3. Same thing here. So 1 3, if any traffic which is coming with all three marking, 1 3 will be dropped first. Then similarly in class 2, class 3, and class 4. Okay, so this is how it works. Classification on layer 2, it's again same thing. uh, it's straight away 3-bit, 0 to 7, 8 classes. Best effort, medium priority, high priority, call signaling, video conferencing, voice bearer, reserve and reserve. So you cannot do it and you cannot assign it. So this is how it's a simple in your CoS. Okay. So any frame that enters in the switch, there have a CoS rewritten to lower priority as a 0. Behavior must be overwritten, that we can basically MLS QoS. It is to activate your QoS, and you can enable that is the configuration part. We can discuss it later. All right, so this is done. Even it has the different RFC as well. Okay, so your EF expedited forwarding was explained in RFC 3246, and AF was explained in the 2597. Class selector was explained in 2474. So it is scalable, flexible. We can modify. It's not like you have done marking at one point, so it can be modified at the second point. Okay, as per your requirement. So it's quite flexible. Okay. So tomorrow we'll talk about the QoS toolset, how to apply your QoS. Okay.